Okay, so good afternoon. We have already started the discussion on theory of estimation. So we discussed what are the characteristics of an estimator. Then we also worked out some problems yesterday. So we will be carrying on that problem workout today also. So for this, I am following that book which you already used in your statistics course in last year. That is Fundamentals of Statistics by S.C. Gupta, 7th edition, which we also referred to in the last year for our statistics course, and we will also be using it for module 1 of Econometrics 1 course in this semester. So if you have got this book with you, that is fine. So I'll be whatever discussion I'm doing, I'll be using this book for module 1. Okay. So now let me share the. Can you see the white screen?
I can see now, sir.
Okay. So we will be talking about sampling without replacement. So you have already studied your sampling theory, in statistics, statistical methods 2 in 4th semester. So there you discussed about simple random sampling with replacement, simple random sampling without replacement. So for simple random sampling without replacement, okay, the variance. So let's say we are considering So let's say we are considering a sampling distribution of a test statistic. So this test statistic, let this be a mean of the population. So in that case, when we are sampling, so let's say we have generated a set of test statistics. Okay, we have generated a set of test statistics, and when we have generated a set of test statistics, so it is creating a sampling distribution. So in that case, let's say sampling distribution of a test statistic. So in that case, we are generating test statistic from a set of random samples which have been generated without replacement from a normal population. So let's say the random sample. Let us consider the random sample, that is x1, x22, xn. So this is a random sample of size n drawn without replacement from a normal population. Okay, so this is drawn without replacement from a normal population. So for each of these random samples that you draw from the normal population without replacement, you generate the sample mean. So you generate k number of sample means, that is x1, x22, xk bar from k random samples. In this case, the variance of this sample mean, that is the sampling distribution of the sample mean, will be given by this expression, that is sigma square by small n, capital N minus n, then capital N minus 1 divided by capital N minus 1. Rangam, just mute yourself.
Yes, sir.
So variance of x equal to sigma square by small n into n minus n by n minus 1, where n is the sample size and capital N is the population size. Okay. Now we'll be discussing about the example 16.3. Okay. So in example 16.3, let's say it's a population of 4 numbers. Population of 4 numbers. So what are those 4 numbers? 0, 4, 6, and 6. Okay. So they are a population of 4 numbers. Now from this population of 4 numbers, you have to draw randomly. So you have to draw a random sample of 2 numbers with replacement. So the possible number of samples is 4. So you can draw the first number from any of these 4 numbers. After you have drawn the first numbers, then you can replace it back into the population, and again you will have 4 numbers. So you can choose the second number. Again you can choose the second number from amongst these 4 numbers. So the possible number of random samples will be first number 4 times. It can be chosen in 4 ways, and corresponding to each of the 4 ways in which the first number can be chosen, the second number can also be chosen in 4 ways. So the possible number of random samples is 16 from this population of 4 numbers. Okay. Now we'll get to the next page. Okay. So sample number. What is the sample? And then we'll have to calculate the sample mean. So 1, 2, 3, 4, 5, 6, 7, 8. So the first sample. So what are the 4 numbers are there? 0, 4, 6, 6. Okay. So the first sample 0, 0. Second sample 0, 4. Third sample 0, 6. Fourth sample 0, 6. Now 4, 0. 4, 4. 4, 6. 4, 6. Okay. Then let us see 9, 10, 11, 12, 13, 14, 15, 16. And 9, 6, 0, 6, 4, 6, 6, 6, 6. Again 13, 6, 0, 6, 4, 6, 6, 6, 6. Okay. So we have generated all of them. Now we'll have to calculate the sample mean. So sample mean will be nothing but what? Average of these 2 numbers. So what is this? Here it is 0 sample mean. Here it will be 2. 2. This will be 3. 3. 2. 4. 5. 5. 3. 5. 6. 6. 3. 5. 6. 6. So now you have got 16 sample means from 16 random samples. Okay. So now what are the values of sample means? So 0, okay, then you have got 2, then you have got 3, then you have got 4, then you have got 5 and 6. Okay, so what are the frequencies of these values? Frequency F. Let us see. So how many number of times 0 is appearing? So how many number of times 0 is appearing here? Just give me some time. Second, I have to write this. 6, 3, 5, 6, 6. So how many number of times 0 is appearing? 0 is appearing only 1. Okay. How many number of times 2 is appearing? Let us see. 1, 2. So 2 number of times. How many number of times 3 is appearing? Wrong, please unmute. Please mute your mic. How many number of times 3 is appearing? Let us see. 1, 2. So 1, 2, 3, 4 times. Done. How many number of times 4 is appearing? 1, only 1 time. No, 4 is not appearing 1 time. 4 is appearing. Well, 4 is appearing only once. Okay. How many number of times 5 is appearing? Let us check. So 5 is appearing 1, 2, 3, 4. So 6 is also appearing 1, 2, 3, 4. Okay. So summation F. Summation F gives what? 1 plus 2, 3, 3 plus 4, 7, 7 plus 1, 8, 8 plus 4, 12, 12 plus 4, 16. So now we can get the probability Px. So probability is nothing but the ratio of the frequency to the total frequency, relative frequency. So we get the relative frequency, we calculate the relative frequency, that gives us the probability of this sample mean appearing, the value of the sample mean. So 0, so probability of 0 appearing a sample mean is 1 by 16, that is 1 by summation F. Similarly 2 by 16, 3, 4 by 16, 4, 1 by 16, 5. 5 will be 4 by 16 and 6 will be 4 by 16. So these are the probabilities of the values of this sample mean, which is nothing but the relative frequencies of the sample means. Now, Next, so now we have to calculate the mean of this sampling distribution, that is mean value of x bar. Okay, that means which is the expected value of x bar. So how many total number of so this will now be given as what? This will now be given by this expression, that is x bar, that is a value, summation over x bar, that is the value of the sample mean, multiplied by its corresponding probability, which is the relative frequency. So what we have got? We have got 0. What is the corresponding relative frequency? 1 by 16. 2. What is the corresponding relative frequency? 2 by 16. 3. What is the corresponding relative frequency? 4 by 16. 4. What is the corresponding relative frequency? 1 by 16. 5. 4 by 16 plus 6 into 4 by 16. Okay. Simplify them. So this is nothing but 0. This is nothing but 4 plus 4 by 16 plus 20 by 16 plus 24 by 16. So denominator is 16. What is the numerator? 4 plus 12. 16. 16 plus 4. 20. 20 plus 20. 40. 40 plus 24. 64. So 64 by 16, that is 4. That is the expected value of the sample mean is 4. Now we have to calculate the variance of the sample mean.
Yes, sir.
So what is the variance of the sample mean? So to calculate the variance of the sample mean, we require what? So we require this expression, that is E x bar square minus E x bar whole square. Okay. So first we have to calculate this E x bar square. Okay. So you have to calculate this E x bar square. So that means you have to now calculate what? X bar square into the corresponding probability of the relative frequencies P of x bar. Fine. So 0 square into 1 by 16 plus 2 square into 2 by 16 plus 3 square into 4 by 16 plus 4 square into 1 by 16 plus 5 square into 4 by 16 plus 6 square into 4 by 16. Okay. So 1 by 16 we take out common term. What we have been said? 0. So 2 square is what? 4. 4 into 2 is what? 8. Plus 3 square is how much? 9. 9 into 4, 36. Plus 4 square, 16 into 1, 16. Plus 5 square is how much? 25. 25 into 4, 100. Plus 6 square how much? 36. 36 into 4, 144. Okay, 16. So 8 plus 36, 44. 44 plus 16, 60. 60 plus 100, 160. 160 plus 144, how much? 304. That gives us 19. Okay. So now we calculate the variance of x. So variance of x bar is nothing but E expected value of x bar square minus x E of x bar whole square. So this is nothing but 19, and this is, we already know it is 4. So 4 square. So 19 minus 16 equal to 3. Okay. So we have got the expected value of the sample mean and the variance of the sample mean. So expected value of the sample mean is how much? 4. And the variance of the sample mean is how much? 3. So that concludes the problem. Next, we get to example 16.4. So in case of example 16.4, so there are a score of 5 students in statistics. So score of 5 students in statistics. Sorry, out of 100 marks. So what are those numbers? Those numbers are 50, 60, 50, 60 and 40. Okay. Now you have to draw out of these 4 numbers random samples. So you have to select 4 numbers randomly of size 4 without replacement. Okay. So without replacement, you have to select 4 numbers from these 5 numbers random. So possible number of random samples of size 4 is given by 5C4, that is 5 factorial by 4 factorial into 1 factorial. So 5 into 4 factorial. So denominator 4 factorial into 1 factorial. So they cancel each other out. So we have got 5 by 1 factorial, and 1 factorial is nothing but 1. So 5. Okay. So now we will have to see what are the possible samples. So we get the sample number 1, 2, 3, 4, 5. Now we have to see the samples. Then we'll have to calculate the sample mean. So the first sample, so what are the possible numbers? So we have got these numbers 50, 60, 50, 60, 40. So the first sample 50, 60, 50, 60. Second sample 60, 50, 60, 40. Third sample 50, 60, 40, 50. Fourth sample 60, 40, 50, then 60. And the last sample 40, 50, 60, 50. Okay. 60, 60. So now we have to find a sample mean, that is the average of these 4 numbers. So for the first sample, what is the average? 50, 50, 100, then plus 120, 220. So this is 55. Sample mean is 55. Second sample 60, 40, 100, 60, 50, 110. So 210 divided by 4. 52.5. Third sample 60, 50, 110, 150, 200. So 50. Fourth sample 60, 40, 100. Then again you have got 110, that is 210, 52.5. Fifth sample 40 plus 50, 90, 158. Okay. So you have got 3 values of sample means. So values of sample mean. X bar. Then what is the frequency? F. Then what is the probability of the relative frequency? So what are the values of the sample mean? So values of the sample mean are 50, 52.5, 55. Okay. Sorry, I have to write here. 50, 52.5, 55. So how many times did 50 appear? 2 times, 82.5 2 times, and 55 1 time. So this has appeared 2 times, this has appeared 2 times, this has appeared 1 time. So what is the total number of samples? 5. So what is relative frequency corresponding to 50? 2 by 5 corresponding to 52.5, 2 by 5, and corresponding to 55, 1 by 5. So now you have to calculate the expected value of the sample mean. So which is nothing but summation x bar into px bar. Okay. So what do we get? 50 into 2 by 5 plus 52.5 into 2 by 5 plus 55 into 1 by 5. So this first term we get 20. Second term we get, so 105 by 5, that is 21. Third term we get 11. So what is the expected value of the sample mean? 20 plus 21, 41. 41 plus 11, 52. Now we will have to calculate the E of x bar square. That is x bar square into P of x. $50 square into 2 by 5 plus 52.5 square into 2 by 5 plus 55 square into 1 by 5. So 1 by 5 is taken outside as a common factor. So now we have got 50 square is nothing but 2500 plus 52.5 square. So 52.5 square is nothing but so I have to calculate 52.5 square. Just a minute. So 52.5 square is nothing but 2756.25. Okay, 2756.25 into 2. So this is also 25 into 2. So this is 255 square into 2, 2756.25 into 2 plus 55 square. 55 square is 3025. So here we have got 2500 into 2 plus 25 into 2 is 5000 plus 2756.25 into 2. So 2756.25 into 2. That gives me 5512.5 plus 3025. Okay. Now dividing by 5. So this will be 1000 this will be 1102.5, and this will be nothing but 605. So what is the variance? Variance will be 1000 plus 1102.5 plus 605. So this will be 2707.5. Okay, 2707.5. Fine. Now we'll have to find the is nothing but EX bar square minus EX bar whole square. So we have got 2707.25 minus what was the expected value of the sample mean? It was 52. So minus 52 square. Now let us see what happens next. Page 6. So variance of X bar. So this is nothing but 2707.25 minus 52 square. So let us find what is 52 square. 2704. So we are now getting this as 3.25. Now we'll have to find the standard error of this sample mean, which is nothing but root over variance of X bar. So this is nothing but root over 3.25, and what do we get? 3.25 root over 3.25 1.802. Okay, 1.802. Okay, this is not 2.5. This is just a minute. This is 0.5. So here also this will be so we have to find root over 3.5. So this is 1.8708. 1.8708. Okay, so this is your answer to the example 16.4. Now we will be talking about example 16.5. So in example 16.5, there are only three values. So the population contain only three values: 2, 5, and 8. Okay, 2, 5, and 8 are only the three values in the population. So we will have to draw a random sample of size 2 with replacement. So what are the possible number of random samples? Possible number of random samples of size 2 with replacement, that is 3 into 3, which is equal to 9. So now we'll have to see what are the sample number. Sample. Then we'll have to calculate the sample mean. Okay. Sample number 1, 2, 3, 4, 5. So for the first sample will be 2, 2, then 2, 5, then 2, 8. Next sample 5, 2, 5, 5. Coming further down 6, 7, 8, 9, 5, 8. Then next 8, 2, 8, 5, 8, 8. Sample mean this is 2. This will be 3.5, 5, 3.5, 5, 6.5, 5, 6.5, 8. Okay. Now, next. So this will be page 7. So now we'll have to calculate the population mean. So we already know what is the population. Population mean mu. So this will be nothing but the average of these three numbers, that is 2 plus 5 plus 8 divided by 3, which is 15 by 3 equal to 5. Now we'll have to calculate the mean. So we have the value of sample mean. Okay. Then we have got the frequency F. Then we have got their relative frequency or probability. So what are the possible values? The possible values were 2, 3.5, 5, okay, then 6.5, 8. So here we'll have the frequency. Now, how many times 2 is appearing? Let us check. 2 is appearing only 1. How many times 3.5 is appearing? 1, 2. 2 times. Oh, there is one more value which I forgot to mention. Just a minute. So here it will be, or did I mention all of them? No, I mentioned all of them, sorry. 6.5, 8. So how many times 5 is appearing? 5 is appearing 1, 2, 3. How many times 6.5 is appearing? 2 times. 1, 2. And how many times 8 is appearing? 1. So Total number of total frequency 1 plus 2 3, 3 plus 3 6, 6 plus 2 8, 8 plus 1 9. So what are the relative frequencies corresponding to 2? 1 by 9 corresponding to 3 by 5, 3 by 9 corresponding to 5. So corresponding to 3.5 is 2 by 9, corresponding to 5 it is 3 by 9, corresponding to 6.5 it is 2 by 9, and corresponding to 8 it is 1 by 9. Okay. So now we'll have to find the expected value of the sample mean. Expected value of the sample mean, which is nothing but into p x1. So we can now write this as 2 into 1 by 9 plus 3.5 into 2 by 9 plus 5 into 3 by 9 plus 6.5 into 2 by 9 plus 8 into 1 by 9. So what do we get? 2 by 9 plus 3.5 into 2, 7, 7 by 9, 5 into 3, 15, 15 by 9 plus 6.5 into 2, 13, 13 by 9 plus 8 into 1, 8 by 9. So denominator is 9. What is the numerator? 2 plus 7, 9, 9 plus 15, 24, 24 plus 13, 37, 37 plus 8, 45. So 45 by 9, fine. So what do we see? We see the expected value of the sample mean is exactly equal to the population mean, equal to 5. Now, we will have to find the variance of the sample mean. So before we find the variance of the sample mean, we need to find something else. What is that? E x bar square. This is nothing but x bar square into x bar. Okay. So this is what? This is nothing but 2 square into 1 by 9 plus 3.5 square into 2 by 9 plus 5 square into 3 by 9. Then we have got plus 6.5 square into 2 by 9. Then we have got 8 square into 1 by 9. So 1 by 9 is a common factor, goes out. So 2 square into 2 square is 1. 2 square is 4. 4 into 1, 4. Plus 3.5 square is 12.25. 12.25 into 2 is 24.5. Plus 5 square, 25. 25 into 3, 75. Plus 6.5 square. 6.5 square is 42.25. 42.25 into 2 is what? 84.5 plus 8 square is 60. 64 into 1 is 64. Okay. So 1 by 9. What do we get here? 4. 24 plus. So 64 plus 4. 68. 68 plus 75. 143. Okay. So 143. So 24.5 plus 84.5. That is 109. So that gives me what? 252. So 252. So 252 by 9 is how much? It is 26. Fine. It is 26. Now we'll have to calculate the variance of x bar. So this is nothing but ER. Okay. Okay.
Sir, can you hear me?
Yeah, I can hear you. Tell me.
Yes, sir, it's getting off automatically, sir. This one.
Huh?
It's getting off automatically. This app, Google Meet app.
Which one is getting off automatically?
This app, the one I'm using now.
Okay, what can be done? This is beyond my scope also, so I can't help it.
Yes.
So now we'll have to next calculate the sample mean, variance of the sample mean. Okay. So I make a mistake. Just a minute. Hold on. Sorry, this will be 28. This is not 26. This will be 28. Okay. So this is 28.
Okay.
This is 28. So now, so Ex bar square, we already got 28. So we know what is Ex bar. Ex bar is 5. So 5 square. So this is 28 minus 25 equal to 3. Okay. So we have calculated the variance of the sample mean. Now we'll have to calculate the variance of the population. Okay. We will have to now calculate the variance of the population. Population variance. So population variance will be calculated using this formula. That is, what is the formula? The formula is 1 by n, okay, capital N, 1 by capital N, summation x, that is a particular value of the particular value, minus mu, which is a population mean, whole square. Okay. So now, what is the population size? 3. So what do we have? The numbers 2. What is the population mean? 2 minus 5 whole square. Then you have got 5 minus 5 whole square plus 8 minus 5 whole square. So 1 by 3. So 2 minus 5 is how much? Minus 3 square. This is 0 square. This again 8 minus 5 is how much? 3 square. So 1 by 3. So minus 3 square is how much? 9 plus 0. 3 square is 9. So we get 18 by 3 equal to 6. Now you see population variance. Population variance is not equal to variance of the sample mean, but if we take this population variance, so population variance is nothing but sigma square. Population variance is nothing but sigma square, okay, which is equal to 6. Now if we take this expression, that is sigma square by small n, where n is the sample size, and what is the size of the sample? 2. Sample size equal to 2. That means sigma square by 2. What is sigma square? Sigma square is 6. 6 by 2 is equal to how much? 3. Now this becomes equal to variance of the sample mean. So what we get here? We get variance of the sample mean is always equal to the population variance divided by the sample size, that is sigma square by n. Okay, so this is what we get from this example. So I stop here now. Okay, I stop at this example and we will carry this discussion. So I'll have one more class today at 3 p.m. Use the same link. Use the same link, Rangam, to join again at 3 p.m. Okay. So thank you and have a nice day till we meet.
Thank you.
Okay.